Okay, so welcome back. This is part two in our series where we show you how to build and program what's called a sweep frequency response tester. And we talked in other videos in this series what that is and how you can use it. We showed one case where you can use it to test a transformer, and it's a test that's done in the real commercial industrial world to test transformers. We showed you how to build it and program it. And what you can see here is we have programmed this signal generator, function generator, to step its frequency every second throughout a wide range from about 100 to 10 megahertz. And you can see on the scope, we are seeing the output voltage. And in future videos, we'll show you how to also program this oscilloscope to measure the peak voltage coming out of this testing circuit where we've got a transformer here and we're going to test this transformer. In this video, we're going to show you how to do some very simple code to step this signal generator throughout a range of frequencies. And we'll connect this to our computer via USB and run the code. And you can see it will step the frequency of the signal generator. Okay, so now the first thing we need to do is figure out how we're going to communicate with our signal generator so we can tell it to vary the output frequency, and then we're going to measure the results in our circuit on the scope. So we're going to figure, how are we going to connect with this? We know it's going to be a USB connection. It's got a USB port on the back. And again, I encourage you to look at the reviews I did on this. We did a multi-part video on not only this device, but also the software that gives you a nice user interface. In this video, we're going to figure out how we're going to actually talk to this and send it commands to tell it what frequency we want it to output. And we're going to do that every second or two so that we can do our sweep frequency response analysis. So here is the device. It used to be manufactured by Coolertron. Now it's under Joy-IT at joy-it.net. And it's the identical device. And you can see it's two output channels and one external input. It does some measurements. And here is the device, JDS 6600. And if you scroll down, you can see it's got some specifications. And here it's got a bunch of downloads. And the first thing it has is something that's going to be very useful to us, hopefully. And that is the communication protocol, which hopefully will tell us how we can communicate with this over the USB. It's got a manual, it's got a couple data sheets. And here, as a side note, it's got the software we showed in our, I think it was the part two of our review of this. It's got a very nice UI that allows you to access the device on your computer. And also it's a nice way to set up the arbitrary waveforms very easily. You can actually draw out the waveform in this software. So very nice software, and thankfully it's now under the manufacturer. Before you had to go to some dodgy website to find it. But anyway, what we're going to do is focus on this communication protocol and hope that it gives us enough information that will allow us to send commands. So here is the downloaded communication protocol, JDS 6600 Joy-IT, and here's a nice little summary. It says for communication needs to be 115/200 baud rate, 8 data bits, 1 stop bit, no parity. So that's going to be very useful. And here is a summary of the format of the commands. You can see the command we're going to send over the COM port starts with a colon, and then it's got a choice. You can have a W, an R, an A, or a B. Now, W is for writing commands, sending a command to the device, which we're going to want to do if we're going to send it a command that says change to 1 kilohertz output frequency on channel 1. So we're going to need this. The R allows us to read like a setting. What is the setting of the device? What is the present frequency setting or whatever? So there's a write command and a read command. The A and the B we're not going to use right now. Those are basically for dealing with arbitrary waveforms, where if you want to read or write the status of the waveforms, we're not going to need that. So we're going to focus on, we're going to have a colon, then a W and or an R, and then there's going to be a function code. So there's some kind of code that says, for example, write 1 kilohertz to channel 1. So there's a code that's for the frequency at channel 1. So we got to figure out what that is. and then an equal sign, and then a data field to set what value we want. And then at the end, we're going to have a carriage return and line feed. Basically, to set the frequency, it's going to be colon W with some code equals some data field with a /r/n. All right, pretty straightforward. Now, if we look at waveform settings, here is where, for example, we can say we want channel 1 to be a sine wave or a square wave or a pulse. But in our case, we're going to want a sine wave. So we know the format's going to be a colon W 2 1, which defines the waveform for channel 1. 2 and 1 means waveform for channel 1. 2 and 2 means waveform for channel 2. All right. So if we set W21 equals 0, we're saying we want a sine wave coming out of channel 1. Pretty straightforward. So we're going to probably need that. We can also do it manually before we run the test, set it to sine wave. But just so we know, we can set up the sine wave. And then the next one is frequency settings. Aha, this is what we're going to need to set the frequency. And for example, if we set a W23 equals this number, so it's 25786, 1. The 25786 is the frequency, and the 1 specifies whether we want hertz, kilohertz, megahertz, millihertz, or microhertz. So the 1 means we want kilohertz. So this is going to be very useful. We're going to know we're going to want a colon W23 equals some value, whatever the value of the frequency you want, and 1 is if we want it in hertz or whatever. So that's pretty much it. It tells us how to set it up to be a sine wave and how to set up the frequency. And we can look at the range. If we want the output voltage to be a certain range, we can do a W25. So now we've got this figured out, we can go and start writing some code to just send these very simple commands to set up the function generator. So now we know that if we're going to be accessing our signal generator on a USB COM port, we're going to have to know what port that is. So here I've fired up Device Manager. Just go into search and type in Device Manager. It's very, very useful. It shows you all your connected devices. And down here you can see ports, COM and LPT. We're not going to be using LPT, which is line printer. We're going to use COM ports. And you can see I've already got a USB serial port. I've got an Arduino hooked up, an unrelated device, but I don't have my signal generator turned on. It's hooked up to its USB and connected to the computer, but it's not turned on. So I'm going to go turn it on, and I want you to look at this ports section to see if anything changes. So I just turned it on. You can see suddenly we've got a new device under ports, and you can see it's COM5. So I've got this USB serial CH340 on COM5. So now I know if I'm going to talk to the function generator, right now I'm going to use COM5. So that's helpful. Again, I've done videos on how to access the COM ports. Okay, so now we've jumped into Visual Studio. And again, if you haven't written software, I've got many, many videos showing you how to do things like this. I've even got a brief series that shows you how to write your first software application. It's really very important if you're going to be doing anything technical or engineering. And here is a very simple C# Windows Forms .NET application that I just opened up and added some very few components to start us off to get ready for what we're going to be doing. So this is called SFRA, Sweep Frequency Response Analysis. And really I have nothing here except for I've gone to my main form, the default form, and I've added two things. I've added a chart because obviously we're going to want to plot the voltage versus frequency. So I've gone to Toolbox and down to Data and Chart, and I just drag and drop that. And also we're going to need a timer. So up here I've gone to Timer, and I've drag and dropped the timer, and you can see down here I've got a timer, a system timer. That's going to allow us every second or two to get a notification and tell the function generator to change the frequency, and then we can make a measurement. All right, so really very simple Windows Forms application. Now I've also added two classes. All right, so I go up here to our project, right click, add new item, and the first thing it selects is a class. So I added two classes. one called oscilloscope, and you can see it's empty, and one called signal gen for signal generator. So we're going to have these simple classes that later on, if you want to get fancy, you can do all kinds of stuff with. But as we said before, this is going to be very simple. We're just going to send a notification to the signal generator to change the frequency, and then read the value on the scope. So that's about it. Here's our Form 1, our standard partial class. And I've added two lists, public list of double called freqvals, which is going to store each frequency that we set the signal generator to. And that's a list of doubles. And then we've got voltage values, and that's a list of each of the red voltage values off the scope. And we're going to keep those in lists, and then we can very easily plot those. Again, I've done many videos on plotting in C#. This will just keep those values that we can automatically plot. Here in my public Form 1, the standard initialized component, and then I am instantiating the oscilloscope class as the DS1054Z, which is my Rigol scope model number, and then signal generator is the JDS6600. So right now they're blank classes, but they're just I'm just instantiating them. And here is my timer1.tick. Basically, when I added this, I just double-clicked to get this event handler. And now I'm just doing the standard design that we always do, saying what we're going to do in this application. And in the timer1.tick, we're going to increment the frequency of the signal generator and then read the V peak to peak from the scope, and then add those to these lists to plot them. All right. So really very straightforward. So as we know, the first thing we're going to have to do, we've already looked at this JDS6600 signal generator. We're going to have to connect to the USB COM port. We saw it was COM port 5. So we're going to have to connect to that and maybe configure it a little bit. And then once we've got that figured out, we're going to do the same thing for the Rigol scope. So we're going to talk about that in the next video. But here we're just going to do a very simple: open the port, configure it, and then send it the frequency every 1 or 2 seconds of this timer tick. So now we know we're going to have a COM5 port we're going to have to open. So I'm going to make a variable public string, and I'm going to call it txt_com, and that's 5. So when I open the port, I can refer to this, and we can change this, make it a little bit easier to change, you know, if it's COM4 or whatever. But I'm going to use this. Then what I'm going to do is I'm going to set up a simple method that will allow us to open the port using that number. So I'm going to go down here, and I'm going to add this method. So I'm going to add this simple method, private void open COM port. And I'm going to refer to this serial port, and I'm going to call it funcgen port. And in order to do that, I'm going to go up here and define serial port, funcgen port equals new serial port. And of course, I'm going to need system.io.ports. All right, so now I've got my port, and you can see we're going to define the baud rate that we saw in the documentation, 115.200, data bits 8. And the port name is going to be COM plus our COM5 text, txt_com. So once I've got that, I can say try to open. So I'm going to say funcgen port. I'm going to do a serial port.open, and it will try. If not, there'll be an exception, and I'll throw up my message box that says, dude, seriously, you need to plug the device in first and then return. Also, we can set up a text box on our form. We can add a text box and a button here to open the port and show the response. And I'll have text box 1, append text, COM port is open, and it will give us a little bit of feedback. But right here, we've got the COM port ready to open. We just need to have a button that will call this and open the COM port. So now we'll add a button to our form that we can call this open COM port. So I'll go here, and I will go toolbox. I will drag and drop a button, and we will rename it. Well, we'll put the text is going to say open COM, And then we will rename it as BTN COM. And we will double click to give an event handler. And all we have to do here is call Open COM port. And that should be it. So at this point, we should be all set to open the COM port. We can add a text box for some feedback, but this should get us going. So now that we have the COM port open, assuming this all works, I'm going to add 2 lines of code. And those lines of code are merely going to tell the signal generator that we want a sine wave and we want it to be set at 1 kilohertz or 1000 hertz. And we're only going to need these 2 lines of code. So our COM port, we've defined it as funcgen port. So we need a write command to write a string to the USB COM port. So we're going to do a funcgen port.write. And the first one, we're going to define the waveform of channel 1. And to do that, we need a :W for write, and then 2:1, which says for channel 1, we want the waveform, and then equals, and the equal is going to be either a 0 for sine, 1 for square, 2 for pulse, 3 for triangle, and so on. So if we set it W21, we're saying we want the waveform for channel 1 to be 0, which is a sine. And then we have to add this carriage return line feed after it. And that should set the waveform for channel 1 to whatever we want, in this case, a sine. Then we got to define the frequency of channel 1. And the format is going to be :W23 to set the frequency for channel 1. And it's in the format equals A comma B, where A is whatever frequency we want times 100. And B defines whether that value is in hertz, kilohertz, megahertz, millihertz, or microhertz. So we're going to do another funcgen port.write, W23 for frequency. And if we want to set it at 1 kilohertz, we'll say 1000, since this is times 100, 1000, comma 0, which means hertz. So we're setting it at 1000 hertz and with a /r/n. So when we hit the button COM, the open COM button, it should open the port, tell it that we want a sine wave and we want it to be 1000 hertz. So let's start this up. And if we press the open COM port, we should get a sine wave of 1000 hertz. So now, as you can see, I've got on the scope a square wave of about 2000 something hertz. And when I run this, it should turn it into a sine wave of 1 kilohertz. So if you look on the screen, I'm going to hit the open COM port. And you can see it magically changes to a 1 kilohertz sine wave on the function generator. And we're reading that on the scope. So very simple to get this signal generator programmed to the frequency we want. So we're pretty much all set. Now all we have to do is set up the oscilloscope, which we'll do in the next video, and then we can move some of these commands to the system timer, where every second or every 2 seconds we'll update the frequency or whatever. Okay, so that's it for this video. In the next video, we're going to talk about some of the requirements we're going to need to set up the frequencies for this. And then in future videos, we're going to show you how to program this scope to actually measure the voltage going into the scope. So if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care and have a really good day. Thanks.